Hey, it's Ms. Mazen here from CTS. Today we're looking at one of three methods of solving systems of equations. It's called substitution. This is from the grade 10, so that MPM 2D Systems of Equations unit. So what is substitution? It's an algebraic method used to find the exact coordinates of where two lines meet, also known as the point of intersection. So for any given equation, we know that you cannot solve for two variables. However, if you're given two linear equations, you can solve for both variables. And that's what the goal is here with substitution. So let's take it back a little bit. Do you remember how to solve for simple algebraic expressions? So for example, 2 plus 4x when x equals 3. You would simply replace the x value with 3. So that would read 2 plus 4 times 3, which is 2 plus 12. And that gives us a solution of 14. Now what if, instead of x equals 3, x equals 3 plus y? We're still going to use the same method of substitution. We're going to replace x in the expression with 3 plus y. So our new expression would read 2 plus 4 bracket 3 plus y, close bracket, and you're going to go ahead and distribute in order to expand and simplify. Now keep that last example in mind. We're going to be using that exact same strategy to solve systems of equations by substitution. I've broken it down into 5 steps to solve for your two variables in your systems of equations by substitution. Step number 1, label your equations #1 and #2. Step number 2, rearrange one of the two equations so it reads x equals or y equals. Step number 3, substitute your values in step number 2 for the corresponding variable in the untouched equation or the equation that you did not rearrange. Step number 4, use algebra to solve for your first variable. And once you've solved for your first variable, sub it back into one of the two equations and solve for your second variable. Now let's have a look at some examples. Let's put these 5 steps to work. We have a systems of equations here, 2x plus 3y equals 5 and x plus y equals 5. Step number 1, label your two equations, #1 and #2. Step number 2, choose one of the two equations to rearrange. I'm choosing #2. I'm going to move my y variable over to the right of the equal sign so that my equation reads x equals 5 minus y. Step number 3, use the untouched equation, in this case it's #1, and replace it with the values that you found in step number 2, which is 5 minus y. So we're going to replace x with 5 minus y for #1. It'll read 2 bracket, 5 minus y close bracket, plus 3y equals 5. If you notice here, we've made an equation with only one unknown variable. So step number 4, we're going to be able to use algebra to solve. First we distribute, then we collect our like terms, and then we simplify. Y is going to equal -5. Step number 5 now, we're going to use the value of -5 for y, and we're going to substitute that in either #1 or #2. I've selected #2 just because it's a simpler equation, and I'm going to replace y with -5. So that's going to be x plus -5 equals 5. And I'm going to collect my like terms. X is going to equal 10. Therefore, our point of intersection, or the coordinates that we have here, is going to be at 10 and -5. Moving on to example number 2, that's 2x plus 6y equals 14, and 7x minus 2y equals 3. If you notice here, all the variables this time have a coefficient. No big deal, just that in step number 2, where we're rearranging and isolating for the variable, we're going to need a bit more algebra. But let's get into it. So step number 1 is asking us to label our two equations as #1 and #2. Step number 2 now, we're going to select one of the two equations to rearrange. I'm selecting #1 just because all of the terms are divisible by 2, which means that I will be able to isolate for x. So let's get that started first by moving the 6y over to the right hand side of the equal sign and then I'm going to divide out by the coefficient of x to isolate. And in the end, we are left with x equaling 7 minus 3y. And here we just pick up exactly how we did it in example number 1 with step number 3. We're using the untouched equation, which is hashtag 2 in this case. And instead of x in hashtag 2, we're going to replace it with 7 minus 3y. It's going to read 7 bracket 7 minus 3y close bracket minus 2y equals 3. As I said in the previous example, we've now created an equation with one unknown, so we're going to be able to use standard algebra in step number 4 to solve for y. So let's get that started first by distributing, expanding, collecting our like terms, and then dividing out by the coefficient of y. Once we have that completed, y is going to equal 2. Step number 5 is where we solve for x. We're going to go ahead and substitute 2 into either hashtag 1 or hashtag 2 instead of using the value or the variable y. I'm going to select hashtag 1, and replace all the y's with 2. So it's going to read 2x plus 6 times 2 equals 14. I'm then going to collect my like terms, and I'm going to divide out by the coefficient of x, leaving me with an x value of 1. That means our x value is 1, our y value is 2, our point of intersection is at 1 and 2. So to recap, here are the skills you need to succeed solving systems of equations by substitution. Label your equation, rearrange one of the two equations, substitution, and then solve. And just like that, you're a master of solving systems of equations by substitution. Thanks for watching.